Good evening, geometry students. Tonight we're going to do Module 2, Topic 3. It's two-dimensional figures. Our standard for this lesson is GR 3.4. Use coordinate geometry to solve mathematical and real-world problems on the coordinate plane involving perimeter or area of polygons. Our second standard is GR 4.4. Solve mathematical and real-world problems involving the area of two-dimensional figures. Our objective for this topic, you guys are going to model and find measures of two-dimensional objects. And our essential question for this lesson is, how are angles and two-dimensional figures used to model the real world? Got the bell ringer to start. Pause the video here. Try to work the bell ringer. I'm going to wait about 3 seconds and then I'm going to move forward. Let's see how your answer compares to mine. Alright, so our bell ringer. Given that ray BF bisects angle EBD, find the values of X and Y. Okay, well, let's go ahead and mark. So EBD, I'll mark that in purple. So this is our angle. Now BF, the ray that they mentioned right here, it bisects this angle. And what have we talked about? What does an angle bisector do? Well, it cuts that angle into two equal pieces. So we're going to do congruent marks for both sides. So angle EBF, let's see, excuse me. So angle EBF is congruent to angle DBF right here, because BF bisected this angle. Now over here, and you can't see because of my colors, but luckily I have another copy. EBF, they tell us, is 7x plus 10 degrees. And that DBF over here is 8x plus 5. So we have these equal to one another. We're going to solve for x, and then we'll worry about y over here. Alright, so we're set up here to solve for x. I'll change colors here. We're going to subtract 7x from both sides. Bring our 10 down. 8x minus 7x is x. Plus 5 comes down. We're going to subtract 5 from both sides. X is going to equal 5. Alright, so we're going to solve for y. Now, notice that line EC and line AD here are intersecting lines. What do we learn in class about intersecting lines? Well, that this and that this, the top and the bottom angle, the whole angle, not where we bisected it, they're going to be congruent because those are vertical angles. So we need to plug 5 in to see what the measure of this whole angle is, and then put that equal to 3y plus 15, because this whole angle and this whole angle are congruent. So we'll plug in 5. Let's see. We know these sides are congruent, so if we just plug in one side, we'll multiply by 2, because this and this are equal. So 8x plus 5. 8 times 5 plus 5, that's going to be 45. Well, just for giggles, 7 times 5 is 35, plus 10 is 45. So this is 45, and this is 45. So 45 plus 45 is 90. So we're going to switch colors again. We're going to put 3y plus 15 equal to 90. Okay, let's subtract 15 from both sides. 3y comes down. 90 minus 15 is going to be 75. Divide both sides by 3. Y is going to equal 25. Alright, let's scoot up here. So below the bell ringer, we're on page 13. Again, Module 2, Topic 3. Our guided notes. Excuse me one second. I'm going to write the words and then I'm going to read the good stuff to you here. Perimeter. 1 second. Circumference. Area. Alright. A polygon is a closed plane figure with at least 3 straight sides. The perimeter of a polygon is the sum of the lengths of the sides of the polygon. Some shapes have special formulas for perimeter, but all are derived from the basic definition of perimeter, which means around the outside. The circumference of a circle is the distance around the circle. That's also another word for perimeter. So the perimeter of the circle is also the circumference, but for geometry purposes, that's what we mean, the circumference, all the way around the circle. The area, that's the square units inside the circle. What it takes to fill that up on a two-dimensional plane. Number of square units needed to cover the surface. Distance around the circle. All right, let's scoot up just a little here. Underneath we have, all right, the first shape we have here is a triangle. Notice the sides are labeled C, B, and D. The perimeter for this guy, so perimeter equals C plus D plus B. That's just this side plus this side plus this side. Our area formula for a triangle is 1/2 base times height. Notice here the dotted line in the middle. There's that box we learned about in class. But here in the middle it says H, that's the height. So when we need to find area, we'll be looking for that dotted line in the middle. But when we're looking for perimeter, we're just adding the 3 sides. All right, next we have a square. We've labeled each of these S for side. Perimeter of a square is S plus S plus S plus S, 1, 2, 3, 4, or 4 times S, because S on a square, these sides are all 4 going to be congruent. Area of a square is either side times side, or side squared, or base times height. Underneath we have rectangle. We have this labeled length with a cursive L and W width. Your circumference, I'm sorry, I'm looking at the circle on the next page. Excuse me. Perimeter. It's going to be either the length plus the width plus the length plus the width, or 2 times the length plus the width, or 2 times length plus 2 times width. Area of a rectangle. It's going to be your length times your width, or base times height. Excuse me, make that a better H there. Base times height. Let's flip over, and I'll be honest, I'm not sure my packet. One packet I have has circle at the bottom of this page. The other one, this, has it at the next page. So if circle's here, just keep going. If it's on the next page, then flip over with me. Let's go down here. Okay. Lastly, on our little diagram here, we have a circle. Your radius there. Diameter goes all the way across. Remember, perimeter for a circle is circumference. Circumference, I hope you guys remember, is 2 times pi times the radius, or pi times the diameter. For area, circle is pi r squared, or you can say pi times the diameter divided by 2. If we have the diameter, just divide it by 2. If you have the radius, excuse me, diameter divided by 2 squared, because it's the radius squared. Same thing. Radius is half the diameter. Either way, you have to square that times pi to get the area of the circle. Okay, you got it, notes underneath here. Let me write this out and then I will talk it out for you. Excuse me, almost done, sorry. Okay, an equilateral polygon has all sides congruent. Equilateral or equal side polygon. An equiangular polygon has all angles that are congruent. Equal angles. A regular polygon is a convex polygon that is both equilateral and equiangular. So all the sides and the angles on this are equal. You can use the distance formula to find the perimeter and the area of a polygon graphed on the coordinate plane. You can use the distance formula to calculate the radius of a circle, then use the appropriate equations for circumference and area. Okay, let's talk about that. On the left here, should not be new to anybody, this is the Pythagorean theorem. A squared plus b squared equals c squared. On the right side, we have the distance formula. Distance formula is the square root of x sub 2 minus x sub 1 squared plus the square root, y sub 2 minus y sub 1 squared. Let me repeat that. The distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, let's put this to work here. We're going to find the distance right here. We're going to use the Pythagorean theorem. Now, well, I don't have a triangle. How am I going to use the Pythagorean theorem? Well, this is how we do this. We're going to go see where this goes to here, and so both of these line up here. I don't have my straight edge, but so you guys are going to have to trust that I'm doing this right. But we're going to make a triangle here. We're going to count. So 1, 2, 3, 4. Wait a minute. Hold on. All right, so we have 6 across here. 6. And then 2 up. Again, Pythagorean theorem, a squared plus b squared equals c squared. So we have 2 squared. So we're going to make that c. Plus 6 squared is going to be our c squared. We're looking for this. Now we can use the distance formula, and we're going to do that here, but we're doing the Pythagorean theorem here. All right, so 2 squared is 4, and 6 squared is 36. 4 plus 6 is 40. 4 plus 36 is 40. So c squared equals 40. We need to take the square root. We're going to take the square root of c squared and the square root of 40. So now we have c equals the square root of 40. And if we put that into our calculator, it's going to give us 6.324. We're going to round that to 6.3. So the distance here is 6.3. Let's switch colors here. Now we're going to do it using the distance formula. So this will be our x1, y1. This is our x2, y2. Distance formula right here. I like to write it. It's just a habit. But x squared, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, our x sub 2 is 4. So 4 minus negative 2 squared plus y sub 2 is 3 minus y sub 1 is 1 squared. Let's change colors so we can see a little better. Alright, so 4 minus negative 2 is the same as 4 plus 2. That's going to be 6 squared. plus 3 minus 2 is 2 squared. 6 squared is 36. 2 squared is 4. Oh, this looks familiar. Square root of 40. Put that in our calculator. 40 square root 6.324. We're going to round to 6.3. So either way, we get the same answer. Let's go down below here. We have an I do and a you do. Okay. Number 1, page 14. Find the perimeter of the rectangle. So, rectangle, I can tell you that the short sides are congruent and the long sides are congruent. So, once we have one side, one red and one blue, we're just going to do it again, double it to get our perimeter. We don't have to find the length here, the length here, the length here, and the length here is what I'm saying. So, first thing we're going to do, using the Pythagorean theorem, we're going to do like we did over there, and we're going to go from here to where that comes out in there. This is a 90-degree angle. If we count across here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so a squared plus b squared equals c squared. So a squared is 5 squared, b squared is 5 squared, c squared is what we're looking for. 5 squared is 25. Again, 5 squared is 25. So we have c squared equals 50. Now we're going to take the square root of both. C squared is c. The square root of 50, let's see, actually for now we're going to leave it the square root of 50. We will use the number here shortly, so just sit tight. So this guy here is the square root of 50, so is that one. Let's go over here to get, let's do the same thing down here to get this. So we're going to go out from here. Should have made it a different color. That's okay, too late. And we're going to count. 1, 2, 3, 4. 1, 2, 3, 4. So 4, 4. So a squared, b squared. We're looking for it again. So this time, 4 squared plus 4 squared equals c squared. 4 squared is 16. 4 squared is 16. 16 plus 16 is 32. Adjust this just a second because I'm going to go below the line. Alright, we're going to take the square root of c squared, square root of 32. And we're going to leave it like that again just a second. So now we know blue is the square root of 50, red is the square root of 32. So our perimeter is 2 times one side, which is the square root of 50, plus 2 times the other side, which is the square root of 32. Just box that. Now we're going to pull the number from the calculator. Square root of 50 is approximately 7.1. The square root of 32 is approximately 5.7. Switch colors here. 2 times 7.1 is 14.2. 2 times 5.7 is 11.4. You add those two together. I'm below the line, pardon me. So again, 2 times 7.1, 2 times 5.7. Now we're going to add 14.2 to 11.4. It's going to give us 25.6. So our perimeter is 25.6. All right, number 2 is a you do. I'm going to wait about 3 seconds after I finish speaking to give you a chance to pause the video. Try to work this one out. It's going to work the same way. Okay, number 2. Let's go over here. So we need to find out what this side is and this side, because again, this is a rectangle, so your top and your short sides are congruent and your long sides are congruent. for here. So we're going to go out straight down over to where this comes out and then straight up. That's why you need a straight edge. Okay. If we count, now these are worth, let's see, so from here 5, 1, 2. So this is 2. And then up here 2, 4, 6, 8, 10, 12, because these are worth 2 on the side, so it's 12. So to find this guy, we're going to say L for this one and W here. So A squared plus B squared equals C squared. So 2 squared plus 12 squared is going to equal our cursive L squared. Okay? 2 squared is 4. 12 squared is 144. So 4 plus 144 is 148. Hold on one sec. Oh yeah, here we go. I lost my place. My apologies. This is not 2 squared. It's 4 squared. These are worth 2. So 4 squared is 16. My apologies again. Let's just do this. Okay, so 16 plus 144 is 160. So our L squared is 160. Square root of L squared is L. And for now we're going to keep it square root of 160. We'll use the real number in a moment. Okay, so for W, I'm going to go across and up. Since it's 2, so it's 3 across would be 6, and then 1 up would be 2. So again, A squared plus B squared equals C squared, or in this case W squared. So 2 squared plus 6 squared equals W squared. 2 squared is 4. 6 squared is 36. W squared. W squared is going to equal 40. I'm going to take the square root of both, and W is going to equal the square root of 40. So right here in the middle, I'm going to do it in black. We're going to get our perimeter. Just separate that so we're in here. So perimeter for this guy over here, it's going to be 2 times the length plus the width. It's going to be 2 times the square root of 160 plus the square root of 40. Don't worry, I'm going to change it into regular numbers. Square root of 160 is 12.649. We're going to call that 12.6. Square root of 40 is 6.3. These two, so 12.6 plus 6.3 is 18.9. Sorry, we're getting tight in here, guys. Times 2. So our perimeter for this guy up here is 37.8. I know this was a lot. Ask me in class. Reach out, if you need some help. All right, let's flip over. Again, this is another page that printed differently here at home versus what I have in the packet. So looks like this extra space here was added on for some reason. So we're on page 15. We're looking at number 3. These are the you-dos. I'm sorry, these are the I-dos, these are the you-dos. So we're going to pause in between here, give you a second to work those on your own. But number 3, we're going to find the radius of the circle. There's your radius. Now, first we're going to do it because this and this and this and this, these are the same things. They're asking for the radius up here and the area down here, but it's the same circle. We're going to do it, let's see, I'm going to do this one with the Pythagorean theorem, and then we'll do this one with the distance formula. So over here, I'm going to take A down to where it lines up with B and then come straight across. This is going to be a 90-degree angle. This is our A squared plus B squared equals C squared. We go from 2 to 4, so 1, 2 here. And then this guy goes 1, 2. So our A squared is 2 squared plus B squared is 2 squared equals our C squared. Okay. 2 squared is 4, 2 squared is 4, C squared. So C squared is going to equal 8. I'm going to take the square root of both. Okay, so C squared equals 8 squared. I'm sorry, C squared equals 8. We're going to take the square root of both. Square root of C squared is C. And the square root of 8 is 2.82. Okay. Number 4. Find the radius of a circle. Again, I don't have my straight edge, so we're going to have to do the best we can. Excuse me. And we'll go straight across here and straight up to make it. So C is 4, 8, D 6, 3. This is going to be our x1, y1. This is going to be our x2, y2. So we're going to use the distance formula. Distance equals square root x sub 2, which is in this case is 6, minus x sub 1, which is 4, plus y sub 2 is 3, minus y sub 1 is 8 squared. 6 minus 4 is 2, so we got 2 squared there. 3 minus 8 is negative 5. Negative 5 squared, which is going to take care of the negative anyway. Going down here, 2 squared is 4. Negative 5 squared is 25. 25 plus 4, we have the square root of 29. We use our calculator. It's going to give us 5.385. We're going to round that to 5.4. Alright, so we have the radius for these guys. It's going to be important because we're going to need that for the area. So let's scoot up a little bit here. Number 5, excuse me. Find the area of the circle. So, area of a circle. A equals pi r squared. Now, we know from up above here that our r is 2.82. So it's going to be pi times 2.82 squared. Use our calculator. We're going to see that the area is 24.63. Now, it doesn't tell us a unit, so it's going to be units squared. The reason for that is, so this is units times units here, and that's units squared. So anytime we deal with area, not just with a circle, but anytime we deal with an area, it's going to be units squared. Inches will be inches squared, centimeters will be centimeters squared, so on and so forth. All right, number 6. And technical difficulties with number 4, I forgot to ask you to pause. So here, pause, use the same formula, area of a circle. We already have our distance, or our radius. So take a second, I'll wait 3 seconds, and then I will proceed. Okay, area of this circle, this is pi r squared. So we already have a straight edge. We already know up here that our radius is 5.4. So pi times 5.4 squared gives us our area, which is 91.6 units squared. Shift up. So this, your page 15 may contain the problems on the next page, so just hang with me. Guided notes. Excuse me 1 second. A geometric model is a geometric figure that represents a real-world object. A good model shows all the important characteristics of the object it represents, although some of the detail may be lost. Drafters use two-dimensional geometric models to create technical drawings that communicate an object's function or construction. Scientists may use two-dimensional models to record an object's general shape or mechanics in a field notebook. You can use two-dimensional models to estimate the perimeter, circumference, and area of objects. Number 7. Use the appropriate two-dimensional model and the dimensions provided in the image to calculate the perimeter and area of the serving platter. So the first thing I notice, it looks like a square. This side and this side are congruent, which means the other guys are, so this is definitely a square. So the perimeter for a square is just going to be 4 times the side. Our sides are 12.5 inches long. 4 times 12, our perimeter for this guy is 50 inches. Notice this is not squared because we are just going around. This is not units times units. This is units plus units, so it's just inches. Now, area of a square is going to be side squared, or it can be, side squared. Excuse me, I'm thinking about perimeter again. So our side squared. 12.5 is our side. We square that. Our area for this serving platter is 20. No, sorry, excuse me. Looking at the wrong one. So 12.5 squared, our area is 156.25 inches squared. It's squared because it's area. Let's flip over here. Number 8. It's another you do. I'm going to pause for 3 seconds, give you a chance to pause the video, work out number 8, and then unpause, and we'll work this together. Alright, number 8. Use an appropriate two-dimensional model and the dimensions provided in the image to calculate the perimeter and area of the framed art. Alright, so right here, perimeter, area, we have a rectangle. As we talked about today in class, the short sides are going to be congruent and the long sides are going to be congruent. Perimeter is length plus width plus length plus width, or 2 times length plus width. Okay? So we'll say our length, we'll say our width. So we're going to go 2 times 61 plus 40.6 gives us 101.6. Multiply that by 2. We'll get 203.2. So our perimeter, 203.2 centimeters. Okay. Area, base times height, or length times width. 61 times 40.6 It's going to give us an area of 2,476.6 centimeters square. On the edge of the paper there, so sorry about the really special writing. 2476.6 centimeters squared. So the essential question: how are two-dimensional figures used to model the real world? Well, two-dimensional figures, you can look at them at a mirror, a window, a door, just as a few examples, sticking with the construction theme we've been using in class. That's going to end Module 2, Topic 3. The rest of this page, and I believe the next page, we have independent practice, starting right here. You guys will work on your own, get those worked out, ask me any questions you have, and keep practicing, and I'll see you in class. Have a good evening.